All right, now it's recording. Okay, we're gonna get started. Let's see. Back to here? No. Back to, is it here? Oh bother. Where'd it go? This one? This one? No. This one? That's the one. Okay. All right, let's get started. Yesterday we finished up CFA. All sorts of stuff with CFA. My least favorite part of data analysis. Today we're actually going to get on to everything all this is built up to. You spend, again, 95% of your time building up to testing your theory. And then hopefully it works. We'll probably find that it doesn't. So that's awesome. Any questions before we get started, before we jump into mediation, moderation, and how to use controls? Nothing. All right, good. Oh, come on, Laura, you didn't have to.
No.
Okay.
I just raised my hand saying yes.
Yes. All right, let's move forward. So, mediation and moderation. What's the difference? And what are we even talking about? First, I should talk about structural models, I suppose. What are structural models? Structural models are when you take those, when you take those constructs and you regress them upon each other and find out if there is truly a causal relationship, assuming there's some theoretical, logical relationship between them. But we're trying to see if something like curiosity really does cause system satisfaction. And you do that with structural equation models, the structural part of the structural equation models. The CFA is a measurement model, but it's also a structural equation model of some sort. And this actually looks like a path model. It doesn't have all those little items and latent factors and error, but it is also a sort of structural equation model, which is essentially just a bunch of different paths being calculated simultaneously while accounting for error and indirect effects and things like that. What is mediation versus moderation? Mediation says that the effect curiosity has on system satisfaction happens because of or through discovery. So the reason curiosity increases your satisfaction when you use some information system is because when you're curious, you discover. And when you discover, that's very satisfying. And so discovery sort of is the reason, is what's transferring that positive effect from the IV to the DV, independent variable to dependent variable. Whereas moderation, it's a different kind of logic. And people get these mixed up, even senior scholars get these mixed up when they don't use them often enough. And it's just hard to logically argue them. But curiosity increases system satisfaction. But it's stronger, that relationship right here, this relationship is stronger in the presence of high levels of discovery. Or as discovery increases, the extent to which curiosity impacts system satisfaction increases. It's a different kind of logic. I'm going to give a few examples to hopefully solidify that for those for whom this isn't just review.
In the mediation model over there there is some direct effect though, curiosity to system satisfaction.
Yeah,
it doesn't take into account discovery.
Right.
Having
So
another path just
additional
allows you to have any sort of indirect relationship, right?
There is something about curiosity that is satisfying by itself.
Right.
Yeah. But a lot of that, a large part of that happens through discovery. Yeah. So this is what we'd call a partial mediation. Good. We're going to start with mediation, then go to moderation, then go to controls, and then we're going to do it all as well in between with the real data, with our big fat model. So very important to specifically note the transfer effect. It's not just your IV affects your mediator, which affects your DV. It's not just the X to M to Y relationship. There's a transfer. It's a partly explained. Part of the explanation is happening through the mediator. So in this case, what would be a good mediator between interest and learning? Interest has a positive relationship on learning. Because when you're interested, you discover that we've used that one. Any other? What is the reason this occurs?
Money.
Money? Wait. So when you're interested, you get money?
You could. And interest in learning could be influenced by monetary demand.
Yeah, interest.
You're interested.
So if I were paid to learn something, I would be interested.
Moderator. Sort of. Happening back here. I'm glad you brought that up. When given money, you might become more interested.
Hours spent.
Interest leads to more hours devoted, which leads to learning. I like that. That works as a mediator. Yeah.
I was just gonna say effort.
Effort. When you're interested, you try harder, therefore you learn. And that's the reason interest affects learning, is because you actually try harder.
But you also have to have an effect. Interest also has to affect the mediator. There has to be some sort of...
Yeah, which it does in this case. Like with effort, when you're interested, you do try harder. Yeah. Good. So try to remember it's the reason for the effect. If you're ever looking for a mediator, think about why. Why does this affect that? Because often when we argue these hypotheses, when we're developing our support for the hypotheses, we argue all sorts of little mediators that we never actually theorized about. We never put in our model. We say, oh, interest affects learning. That's our hypothesis. Because, when you're interested, you try harder and you're you discover more. Those are all mediators that we just never actually theorized about.
Mediators always interchangeable as independent variables?
You could use them as independent variables, but typically they happen, if you think about temporal precedence, like time order of things, interest occurs before effort. Although you could flip that and say, as you get more engaged, you become more interested. Yeah. Importance of logic and argument. Okay. That's a mediator. And then there's partial versus full. So is there something about interest by itself that affects learning? Yeah. So this is probably a partial mediation. But if there was nothing in particular about interest that affected learning, when we take into account discovery or effort, well, then this would be a full mediation. There are other types of mediation as well. Back to what Bernie was saying, though, there has to be a temporal precedence. The interest must occur, theoretically, prior to the mediator, which must occur prior to the learning. This isn't like a process model where it's events, but the state must be affected prior to the other state being affected. Interest leads to effort, which leads to learning. All right. There are 4 main types of mediation. And I've talked a lot in my videos about these 2, partial and full. I've talked a little bit about indirect, and I don't know if I've ever made a video about bifurcated mediation, or if anyone's ever even written about it in the literature, but it's something I come across a lot. And so we should probably write something. Full mediation is where the x to y relationship, independent dependent variable, is significant without the mediator. And then when you add the mediator, there's no direct effect anymore. That direct effect completely drops out of significance. That's full mediation. And of course the indirect effect has to always be significant. For any type of mediation, the indirect effect has to be significant. Yes?
So that would be the effect, in terms of your actual path.
Yeah.
That would be from the M to the
Yeah,
Y.
the x to the m needs
X
to be
to the M
significant.
needs to be
M to
significant.
y needs to be
And
significant.
to the Y.
Yeah, and if you were to do a bootstrap analysis and actually detect the indirect effect directly, that needs to be significant.
Okay.
Yeah, which we'll do. Partial is where you have a significant direct effect without the mediator, but then when you add the mediator, that direct effect sort of decreases in amplitude and possibly in significance. Johannes, did you have a question? Okay. Indirect effect is where there is no effect, essentially. No effect with the mediator or without the mediator, but the indirect effect is significant. There is something there. It's just, unless the mediator is present, there is no effect. That sounds like full mediation, right? It's not. Full mediation, there has to be this sort of illusory effect, this fake effect, mirage effect, initially, which is actually fully explained in the presence of the mediator. Whereas with the indirect, there was never an effect. There never will be an effect, even an illusory one, unless the mediator's present.
So how do you explain that?
What's the logic there?
What's the logic? I mean, is it really any, and in that case, you have a significant x to m and m to y.
You have to,
right?
yeah. And that's the only thing you have. Trying to think of a good one here.
And you can have a case where that, and then you go back and bootstrap it, and you know that that is a significant
Mm-hmm.
relationship, but you never have a direct x to y relationship.
Never, not once. So there are relationships like this. Things that you think are maybe distantly connected. Probably a bunch that just aren't coming to mind. I don't know if anyone can think of something that's loosely connected. I should have thought of that before I came.
No, that's fine.
Yeah, it happens all the time. You have these things that you know that there is some relationship, and you just can't pin it down logically because it doesn't make any sense. But then you add the mediator, and you're like, oh, it's because of this. That's why we're seeing this. It's an indirect effect, where there truly is an effect. It's just occurring through the mediator. The whole trailer park and tornadoes thing. There's something there, right? There's something there. Well, the mediator is hot, dry, flat land, right? Sort of. People, you park trailers in hot, dry, flat areas, and the hot, dry, flat areas tend to produce tornadoes. So there is no real direct effect there. It's totally indirect. That's probably not a great example, but you get the idea. There's some loose connection.
So you would just see a teeny connection, like you would see them occurring together, but you'd know it wasn't causal?
You'd see them occurring together, and there's no correlation and no causal effect, but you always see them occur. You know there's something there.
But not enough to show up.
But not enough to show as a significant effect. Yeah.
This sounds like maybe this occurs when the mediator causes both.
Causes both effects.
Causes both X and Y.
So actually, yeah, the mediator causes the X. So you'd have to argue that very strongly in the temporal precedence thing. You have to argue very strongly.
That X happened before M.
Before M, yeah.
So could you say ice cream sales and boat drownings?
Tell me about it.
So there's a correlation between boat drownings and ice cream sales.
Is there really?
Yeah.
Sure, hot weather.
But it's hot weather.
Oh, there we go.
That makes
Okay.
sense, yeah.
There's also a correlation between purchasing beer and purchasing diapers. Yeah. So it's because it's when the man goes shopping. So anyway, it never happens for anyway, but never mind. Just saying, there's actually a real study on that. That's indirect. Bifurcated is this funny thing. Bifurcation is when there's no direct effect without the mediator, and then you add the mediator, and all of a sudden, there's a direct effect, which makes absolutely no sense, right? Why would adding a mediator, taking away some of the variance, actually increase the amplitude of the direct effect?
Oh, because they could be IVs. They could be very interchangeable IVs, right?
No, in that case, if they're interchangeable, then it should be swamping out the effect, sucking it away. It's this bizarre thing, and you rarely see it, and nobody ever publishes on it because they always say, oh, wow, that's an error. I can't reveal we had weird data. But I found this, some of you know Deirdre. In Deirdre's data, and in a few other studies we've done, we found this really bizarre finding. She studied military training and life or death outcomes in combat scenarios. And we thought for sure the more training you had in cadet school or whatever, in military school, the more training you had, the more effective you would be in these high stress scenarios. And we found nothing. There was no effect whatsoever. We're like, seriously? That makes no sense at all. So we had also, luckily beforehand, we had theorized that there's something virtuous about good leaders in these high stress combat scenarios. And virtuous leaders, people with high moral values and self-sacrifice, willing to do the best for the team rather than just the best for themselves, those folks would be the better leaders. And we use this as a mediator, and we found that when training leads to better moral foundations, then there's a positive effect through training on effectiveness in these high-stress scenarios. When training does not lead to an increase in high moral foundation, there's a negative effect on effectiveness in these high-stress combat scenarios.
Those are negative direct effects?
So here's what it looked like. I should just, if I were to, let me go back, boom, to here. Let's pretend this is training, and this is effectiveness in high-stress combat scenarios. And this is high moral foundation. As training led, without moral foundation even taking into account, there was no effect between training and effectiveness. When we threw in moral foundation, the positive effect coming from training went through moral foundation. And there was a strong, significant indirect effect to learning, or not to learning, to effectiveness. But the negative effect was then left by itself. You suck out the positive effect, and all you have left is the negative effect, which was directly at outcome effectiveness.
So that was just moral, like strong moral leadership was that mediator?
Yeah.
And then
And it pulls out. So there's a dual effect of training.
There, and then it isolated that negative. So
Yes.
without that mediator, it was sort of
It was muddy.
mixed signal.
Yes, mixed signals. So training has this dual effect, a positive and a negative effect. And so the positive effect is sometimes it'll lead to good moral foundations, and the negative effect is we theorized, we don't know, but we theorized that training can ingrain bad habits and callousness. And so there's this negative effect. And so you sort of prism it, you shoot light into a prism and it bifurcates, it refracts. And so this splits off the negative and the positive effect. And the positive effect is left free to go through the mediator, and the negative effect goes direct. And sometimes it's the other way. The negative effect goes through the mediator, and the positive effect is direct. But this is what's called bifurcation, where before there's no effect, and then after both are significant because there's a dual effect from the IV to the DV. Sounds like magic. It's just numbers, right?
Has Jitter got any more mileage from the study?
Yeah, we just submitted it to a leadership journal.
Great.
Yeah. Andreas.
I'm a little stuck with the term full mediation. If you look at,
Okay, yeah.
at the graph, the next slide, this slide, for me, full means that when you have the mediator, then it's
Everything should be significant, right? No, it's the explanation of the effect it's fully explained through the mediator. There's nothing without the mediator, right? No. Well, there's nothing direct when the mediator is present. It's all explained fully through the mediator. Okay.
And would you ever see that?
Oh, all the
in
time.
Statistics?
Yeah, all the time. Yeah, there's one several of you are familiar with, and many of you have worked with burnout, right? Burnout and stress and satisfaction at work. Burnout fully mediates the effect of things like ethical concerns and resource demand gap, things like that. These small things that cause burnout, really, and that also affect satisfaction at work. Burnout fully mediates those effects. It's only insofar as they cause burnout that they affect your satisfaction.
I've been interpreting those kinds of things as saying leadership ought to concentrate on the burnout issue because that's
Burnout's the thing.
Burnout's the thing.
It's not ethical concerns. It's
Right.
when it leads to burnout.
Right, so
But
if
what's
you
causing
want-
burnout? Ethical concerns. So you gotta sort of go back to the source.
But if you wanted to be most effective, if you think about there are nodes in an organization where you hit something, hitting burnout, for example, would get you a great deal of mileage.
It would, but a bit off topic, but burnout's the top of the flame that's burning the rope, that's holding the sandbag, that's going to drop on the knife, that's going to... so the bottom of the flame is ethical concerns and resource demand gap and work-family conflict and things like that. So nip at the bottom.
In the case of daydreams, the moral foundation
Mm-hmm.
of the positive effect was a full mediation or a partial mediation?
Bifurcated.
It was bifurcated.
Yeah, bifurcated. Training to effectiveness in those scenarios was bifurcated because it had a dual effect. Anyway, so if you come across that and you're like, oh my goodness, that makes no sense, now you know. It's bifurcation. And who do you cite on that? I have no idea. I haven't written a paper yet. So there might be one out there. If you ever find one and it's not called bifurcation, that's just the name I gave it. If you find it out there, let me know. I'd be very interested to read what they have to say. I should just email, what's his face?
Just ask Lori.
Mackenzie. Yeah, or ask Lori. No, no. Sorry, Lori. No, I should just email Mackenzie or Preacher. They'd know. Or Kenny. He'd know.
James, do you want to look it up?
You can try. I've looked it up too, but you might have more success.
That's what I'm gonna do from now on, James.
Just defer.
Need a reference after wiki.
Okay. Yes.
I guess I
Just
want to be able
have
to.
a question on the, you can go back to the indirect effect. So if you run your mediation and you get indirect effect, then you should assume that your original IV
Mm-hmm.
was actually not a good IV. Because your mediation is showing that's not showing any effect.
There is no effect. Yeah, there's no effect on the
So-
dependent
so
variable,
then you-
except through the mediator.
Okay, so then your model really changes.
It does.
Yeah.
The story
The
changes.
story changes.
Unless that was your story to begin with.
Mhm.
Yeah. And then the most important, how do you actually determine whether mediation is significant? There are several approaches, and we'll use two combined. The Barron and Kenny approach, that's referring to Barron and Kenny, is it 78, I think, something like that, 1978, or 73, or 83, or I don't know. Something like that. Look up Barron and Kenny, you'll find it. Where you run the mediation, you run the model first without the mediator, see if there's a direct effect, like in that first column. Run it without the mediator, then run it with the mediator, see if there's any change to the direct effect, and then you know, well, it's one or the other. But that's actually not sufficient. You need to then test the significance of the indirect effect, which you do through bootstrapping. Run 500 plus bootstraps. And there's a value it creates for you in Amos, or in Smart PLS if we end up using that. What is the bootstrap? Bootstraps are you randomly sample part of your sample, and then there are different ways to do this, but you can replace randomly certain cases with the mean, or something like that. And then what that does is you do that 500 times randomly, and then it produces a much more reliable estimate of the effects. Did I get that wrong? Anybody who actually knows statistics? Pretty sure I'm right on that one. Sounds good? Good, no red flags. All right. That's how it works. In stone. Okay. Let's do it. So this is what we were hoping to test. This is our original model from Friday, like a week ago. So let's go test this. And we're going to test this using, I'm going to show you real quick how to do it with a fully hybrid model. And then I'm going to show you how to do it with the, oh, whoops, you can't see my screen. Every time. You'd think I'd learn. There we go. And then I'm going to show you how to do it with the composites, because that's just simpler for instruction. All right. If I were keeping the CLF, which I never like keeping, I would just leave it in here and then start creating stuff. Let me save this as.
Why don't you like keeping?
It just creates issues. And it severely complexifies the model, if that's a word. It makes it much more complex. So many more parameters.
So you can start over from scratch then, also.
You could start from scratch,
That'd be another option.
but why? Here we go. Check it out. Hybrid SEM. Save. And what I'm going to do is I'm going to look at my model. Here's my model. Information acquisition and decision quality are on the far right. And we've labeled them now as system success. So assuming I'm using the second order model, I'm going to get rid of these covariance arrows, going to the DV. And then what are our mediators? Usefulness and enjoyment. Here's usefulness and enjoyment. You have to move the X every time you tap on it, and you've probably figured that out by now, or else it opens up the properties of the object. And then these guys are all our independent variables, so I'm going to leave them covaried. Amos assumes you covary exogenous variables. So we do. I'm going to move some stuff around.
Forgive me, James, why are you taking the covariates off the?
Oh, come on. It's not going to let me. Oh, because we need to regress upon them, and you cannot both regress and covary in Amos.
Okay.
Yeah.
Big pictures, we're now looking at mediation now.
We're now looking at mediation. I'm building a structural model to test mediation using a fully hybrid model. You might not want to follow along on this. What we're going to do, it's just going to be real messy just to sort of show what we're doing. I'm just going to move things over like this because they're all connected to the CLF, which also makes things difficult to move. Pain in the rear. I'm just going to go like this. And these don't count because they're part of a second order factor. And we're going to start throwing in regressions. That's the single arrow thingy. So, to joy, to usefulness. Usefulness. Ah, there's a constraint. We have to. You can't regress upon something that has variance that is constrained. We've constrained the variance here. So let me set that back to nothing and put it here, 1. And this is, I think, why I prefer to do it on the path rather than in the variable, or rather than in the latent factor. That's right.
Why don't you build composites and just do it?
Because I want to show everybody how to do it hybridly. And then I'm going to show you, yeah, with composites, which is so much easier. But some journals will require you to do it fully hybrid because it accounts for error better. Yeah, just don't do it unless they ask you to. Yeah.
Forgive me, I just don't seem to get it.
What are we doing?
Yeah, we're accounting for mediation now?
Mm-hmm.
Okay.
It's all good.
There we go. This big fat mess, what have I done? I've connected playfulness to the mediators and the mediators to the DV. So all the IVs are connected to the mediators and all the IVs are connected to the DV and then the mediators are connected to the DV. I've made this, except I've added direct effects here. And so this would be this model with mediator and direct effects. So we haven't actually tested this one yet. But this is how you would build it, like this. I'm not going to run, I'm going to run it once to see if it even works. We need errors, this little boxy thing, error, error, error. Anything endogenous, anything with an arrow going into it needs error. Yes, Andreas?
Endogenous, the mediators, is it endogenous?
Yeah, the mediators are endogenous. Anything with arrows going into them are endogenous. You'll notice everything in this model, even the items that have arrows going into them,
What about your
have error.
controls?
The controls, I have not added those yet. Would this be a good?
Control, you have to go and put items over there.
You would add them now. Yeah, as soon as you start testing mediation, moderation, anytime you test a hypothesis, you need to have those controls in there.
Right, but you need to put an arrow on it.
If it's endogenous, usually controls are not endogenous. They're just exogenous. They throw out arrows.
Right, yeah, so you covary them, but that,
Yeah, you could covary the error or the controls, which we'll do.
yeah, you covary controls, but there's no, so what's going on is fine.
Nope. This should run. Yeah. We'll see. Please run. Please run. Please run. It didn't run. Of course it didn't run. Probably due to the common method bias, the CLF. Yeah, it's due to the CLF. So, another reason I hate using the CLF. Should I try to fix it or should I just ignore it? For the purposes of this workshop, would you guys like me to fix it?
Fix it.
Okay, I'll fix it.
Fix it.
E13 and 14. E13 and 14 are up here. They're covariate right now. I'm going to get rid of that covariance arrow and run it again. Why did I do that? Because it was something they had in common, and it ran. What do you know? There we go. But now it's all screwy again. Oh, look at that. Everything else looks fine. So you have to go in and fix your CLF again. Let's go do that. I'll move the constraint over to here. 1. Deleted. Run. Hope it works. It's just this little game we played yesterday.
Acceptable to have 2 constraints.
Didn't run. I've never run it with 2 constraints, but I imagine it would actually run. Yeah. Actually, let's do this one.
James, these constraints you are playing around, you do that randomly, there's no logic.
Sometimes randomly, sometimes I go look at the estimates here. Go look at and see which one has the highest error. Down here in the measurement model. Here's joy. Look at all this error. They're all enormous. Joy 3 is the one with the largest error, but that's what we had it on before, and that didn't work. So we'll try Joy 2. Is there anything else with a major error? And if I can't get it to work at this point, I would argue against common method bias. I'd be like, you know what, we don't need common method bias.
James, is there supposed to be a direct arrow between playful and system success?
Between which one?
Playful and system success?
Yes, is there not one?
I don't see one.
You're correct. I should add that. Thank you. Hey, it ran! And it ran poorly. So, at this point, I'd probably get rid of the CLF. Because I'm just not that patient. I also forgot a line between playful and system satisfaction. There we go. Kill the CLF. And I can't because it's red. Why is it red? Because it's Amos. Let me save it. Go to a different model. Go to this model again. Oh wait, was that the model? No, we're on the hybrid. Hybrid, SEM hybrid. No. Oh, it didn't show up. Here we go. Right here. There it is. And now it's not red and I can kill it. Okay, now this should run. It ran, and it looks fine. And here are the effects. And if I want the R squares, I can use squared multiple correlations. Right here, squared multiple correlations. Check that. And run it again. And the up arrow will show me all sorts of stuff. Here is the R square for system success. 49% of the variance is explained, which is pretty darn good. And the mediators, let me zoom in here. Tolerable, 0.19, pretty good for joy, 32%. Here are the effects. Are they significant? We have no idea until we go look at the output on estimates, scalars, regression weights. And here are our estimates. From playful to joy, yes, significant. Playful to usefulness, significant. These ones not. Atypical use has no effect. Awesome. Comp use, yes, significant at the 0.05 level. Yes, comp use. Useful, joy, yes. Atypical use, again, no effect. Comp use on system success, nothing. So now these might be fully mediated. We just have to test without the mediator first. I'm going to go do this in a path model now so everybody can follow along and do it with me. This is just to show that you can run a fully hybrid model and it works, assuming you don't have a CLF in there throwing off your groove. Any questions about the hybrid model and why you would ever do this? And
What are the advantages?
the advantages of the hybrid model. Typically, you will have better model fit. when you run a hybrid model than when you run a path model. In a path model, you have a maximum number of degrees of freedom of something like, less than 40, because you only have a few constructs. Here we have like 50 different variables. So we have mega high maximum for our degrees of freedom, which allows us to have better fit in comparison with our chi-square. Now our chi-square also inflates, but we're counting for more paths. Anyway, it's this weird little balance, but my experience has been that typically, not always, but typically I get better fit in the hybrid model. Also, you explicitly account for error in a hybrid model like this. Whereas in a path model, which I'll show you next, we don't account for measurement error because there's no measurement model in our model. It's just a path model between the constructs.
So if you have a path model.
Yeah.
If you're running in the model you run and it's not fitting,
Mm-hmm.
go back and run on the path model, it might fit better.
In the hybrid model, yeah. Yeah, if you run it back in the hybrid model, it'll probably get better fit.
You get fish.
Yes. Any other questions about the hybrid model? Because I'm going to dump it. Yep.
So, to me, the regression loadings look just the same as these other, there's just an error. Are they the same?
Yeah, what's the difference? That's a super good question. What's the difference between this arrow right here, oh no, this one right here, 0.51, from usefulness to system success, and this arrow right here? Nothing. Think about it statistically. What is this representing?
The whole top.
It's representing the extent to which system success correlates with all of the items. What do these represent? The extent to which this item correlates with all of these items. It's the same thing. It's like throwing it in as another item. Interesting, huh?
So they could all be beta weights as well.
They are all betas. They're all the same number, yeah. They're standardized regression weights or betas. Yeah. Mind blown. Yes?
This is interesting. Where is the constraints that you put on this? My model is saying it needs one more constraint.
Oh yeah, you remove the constraint from system success in order for it to run, and then I had to add it to one of these paths from the lower order.
Okay.
Yes?
So Mike just sent me a note saying that you muted all the online people that trying to ask questions and you won't let them.
Am I muted?
Well, it's up to you how you.
You guys can unmute yourself. Can you hear me now? Can you hear me now? Hey Mike, can you hear me? Yes. Oh good. Okay. So what's the problem?
I think there was a big
Did they ask questions?
Oh, you're asking questions. Why didn't we add an error to playful? Because playful is exogenous. There's no arrow going into it. Here's playful over here. There's no regression upon playful, and so there's no estimation error. That's why I didn't add it to playful. We didn't add it to playful, atypical use, or comp use, because there's no single-headed arrow or regression going into it. Playful is oh, she answered it for us. Thanks, Linda. Can't hear him. Do you hear James? Yes, I do. Yes. What is that face? Oh, turn on your... That's a scrunchy fat. Okay, turn on your speakers, maybe? Yeah. Or it's your internet connection. All right. Oh, that's why I can't hear you. This is way down. I'll be able to hear you from now on. I turned up the volume on my computer. Sorry about that. So if you have questions, just holler. Back to work.
So you're looking at these are the correlations for regression weights.
It's a very similar idea and measurement. Yes, is the answer.
How do you change those back and forth? One's standardized versus unstandardized.
Standardized is here.
Okay.
Unstandardized here. Yeah.
And standardized are the regression weights, unstandardized are the correlation, right?
No, that's a false statement. Unstandardized is the exact slope of the line. So if I change playfulness by 1 unit,
Yeah.
to what extent will I change in units, Joy? Whereas standardized is the relative effect. If I change playful by 1 unit, what is the relative effect on joy?
Right, the unstandardized, or the actual units of the study.
Is that, yeah. So if we did a 1 to 5 scale, this could be up to 5, Or if we were looking at predicting income, this could be, tens of thousands or hundreds of thousands for the unstandardized, because it's just the exact slope.
Okay, so then for the correlations then,
Those are on these 2-headed arrows when you're standardized. Yeah, those are correlations.
I just got confused with that.
It's all good.
It's all good.
Any other questions on this, or should we move to hybrid or path model?
And if you were gonna put a control in, where would you put it?
Oh, yeah. We'll do that in the path, but you do it the same here. You just throw in the variable here and regress it upon whatever you think it should be regressed upon, or covary it with whatever you think it should be covaried with, depending on if it's endogenous already or exogenous. So we covary it with these guys that are covaried, and we might regress it upon system success, or if we think it might have an effect on usefulness or joy, we'd regress it upon those.
And you said they're always exogenous.
The exogenous ones are the ones that don't have arrows going into them. Oh, and controls are always exogenous, yeah. You rarely predict a control.
For the constraints, you constrain the IVs and the mediator, but never the GD.
I constrain them. Wrong word, I think. What?
My question is, which one do you have to constrain? Not the DD, the exogenous, but the
To control?
Oh, here in this
I-
mindfulness, typically use, confuse, joy, and usefulness. Which one you have to constrain?
I'm constraining nothing. I mean, there's some paths that are constrained from our measurement model. Do you mean which ones do I control effects for? Control, you'd throw the control onto whatever you think it might affect. So let's say we're controlling for Excel experience. Do we think experience with Excel will affect your success with Excel? Probably. So we'd control for it there. Will it affect the extent to which you feel it's useful? Yeah, probably. And the amount of fun you have with it? Probably. How about the comprehensiveness of your use with it? Yeah. Yeah, all of these, probably it affects all of those, the extent to which you have used Excel. So we'd covary it with those independent variables, and we'd regress it upon all the endogenous variables. Yeah.
You had constrained the Latin useful joy before.
Yes.
Now, when you're doing this hybrid model,
They can't be
they can't be.
because you're regressing upon them.
Yeah, so do you need to constrain any of the paths?
So I did, yeah, I moved the constraint up to the path here. Yeah. Well, let's move on to a path model. Let me save this just so we have it. Okay, yesterday we created composites. So I'm going to go File, New, and open up that composite file. Data files, grab the data. I would love for you to follow along on this one, or do it with your own data. I'm going to use, it's whatever it was called, _C is what it default names it. And hit OK. You know what they need? They need like little soft stuff here. This is not comfortable. No, I'm good, thank you. Thank you, though. You're very kind.
Are you getting the one with CLF?
I'm going to do the one without CLF because I determined that we didn't have a common method bias problem. But if you were to use the one with CLF, you do it exactly what I do. Exact same. You don't throw the CLF composite in there. You just leave it alone. Okay. Oops. Here's our model. Playfulness. We're going to throw these in there just like that. They're in this white stacky thing. I'm going to open up this a little bit. They're at the very bottom. And if you want, here's a little trick most people don't know. Go to View, Interface Properties. Instead of paper size portrait, I'm going to change mine to landscape and hit apply.
A4 or,
I'm going to use A4 because it's longer.
This is the database with the C.
_C, yeah. There we go. Now we have more room
Is there,
horizontally.
is there a way to
get rid of the gray background to make it white?
Yeah, you can make the background white as well. View, interface properties, colors. Here we go. Background, white. No. It's somewhere else. That's not it. Selected is blue, highlighted is red. No, oh bother, where page layout is it? Where did I put it? Pin size misc. No, alternate to no. I've done it before. Anyone know where it is? Change the background color over here. Instead of gray, make it white. I've done this.
It's under interface properties.
That's what I thought.
I could never find
This is critical.
it. Well, it just matters when you do a screen grab.
Well, I'll teach you how to do
Okay.
if you want.
Couldn't we just change the paper size to be huge?
You could just zoom in. Yeah, but there is a way. I've done it.
There is.
Oh well. Let me know if you figure it out. That's what I thought. Doesn't matter. Okay. I'll teach you how to do a screen grab where it doesn't even affect the colors, even if you're over the background. In fact, I'll show you right now just so we have it. If I create, oh, that's right. If I create something like this,
Yep.
oh, it's slightly transparent. This might have an effect. If I do a screen grab of this thing, right, and stick it in Word, paste it in there, and then I go to click on it, format, color, set transparent color. You can click on the gray, disappears. You still have that transparent issue there, but pretty close. Usually it's just your error terms over there. Okay. Anyway. Okay, let's make our model. There we go. Okay. I'm going to drag out all of our stuff. And I'm going to use, yeah, we're good. Okay. I'm going to use the not second order factor.
So not use system.
Yeah. I can, I suppose. It would actually make things way easier. So I probably should.
These are the composites.
And you still learn just as much.
These are the composites we did yesterday, right?
Yeah. In fact, I think it will, since you'll learn just as much and it'll be simpler. Okay. I'll get rid of info, acquisition, decision qual in just a sec. There we go. So I'll use that one. It'll simplify things for today. Comp use, playfulness, and joy. Oh, no. Atypical use. Those are the variables. We can move them all around. We should probably just do them in the same order. So playful comp A, useful enjoyment, and system success. There we go. Like that. Comp latent. Yeah, that's probably what you called it. Yeah. I actually assessed comprehensive use more objectively and asked them exactly which features they used instead of having a latent set of measures as well.
At this point, we should not have our controls.
Ah, you should at this point. Let's throw in our controls. I just wasn't teaching about that immediately. Let's see. Controls are gender, age, and education. Thank you for that reminder. Age, education, gender. Gender's a funky thing. That sounded wrong. Gender is a funny variable. It's not metrically meaningful. The numbers mean nothing. I think in this case 1 is male and 2 is female or something like that. But do females have more gender than males? I don't know. But not in the sense we like to think about it. If I increase the value, if there was a third gender, a 3, and somebody had a 3, would that be more than a 1? No. So how on earth can we get away with regressing gender upon system success? What does that even mean if I get a positive effect on the relationship between gender and system success? We can actually do it because gender is binary. What it means is whatever the higher value is the how to say this properly is the default value, and the other one's the reference point. So let's find out which is which. Which one's male and which one's female? Anyone know off the top of their head? No, I'll find it. It's right here. I think it's male is 1, female is 2. I'll just find out.
So James, system success, you just combine the 2
Hmm?
System success, you combine the 2
Yeah, in the measurement model, I had a second order factor, and the composite was created for that second order. If you didn't do that, don't worry about it. Just use the 2.
Says 1 is male. Says 1 is male.
1 is male, 2 is female. Okay. So that means, let's say we have a positive effect between gender and system success. If 2 is the higher number and 2 is female, that means as gender increases, right? As you become female instead of male, that sounds so wrong, but you know what I'm saying. As you are female instead of male, the effect is stronger. Therefore, for females, we would observe stronger effects in system success than for males. Male becomes this reference group. Whereas if the effect was negative between gender and system success, that means males have more success than females. It's essentially like doing an ANOVA and finding out the difference it means.
How big of an effect difference would we want to see before we made it a moderator instead of a control?
It would have to be we'd have to want it theoretically, not just statistically. Yeah.
Okay.
So we'd have to have a good theoretical reason. When do you moderate by gender? When you're doing a medical study. In social sciences, we've moderated by gender. We've done that. I mean, we've so done that. And unless you're doing something fairly blue water, fairly new that nobody's ever seen before, I wouldn't moderate by gender, because everybody's like, yeah, we know, men and women are different. Woo! Shock of the century. Right? Not that interesting, unless it really is interesting and it has meaningful impact on business, the way you treat men and women in organizations, things like that. Or if it has a difference in medicine, this medicine works for females, but when you give it to males, it kills them. So we want to know.
Good to know.
Yeah, really good to know. Okay, what do we regress it upon? Whatever we think it might have an effect upon. Gender should have an effect on system success because I say so. Also, because I'm not going to go into that. But we're going to say it has an effect. Age, also probably shouldn't go into that. But there's a lot of research that shows that age does have an effect. There's something called a digital native and a digital immigrant. I'm a digital native.
I see, 2002. Oh, you didn't have that on.
Yeah. Thank you, Bill. That's awesome.
I rejected the research.
Yeah.
Sounds great.
Anyone born after 1978, I think it is, or 75, is a digital native.
So you did 2008 then? You went and wrote about it again.
You're just going to get it for being, you know what you get for being helpful, Lori?
Nothing.
Flack.
I get love.
That's right. It's just,
I know this is love.
it is love. It's the way men show love, is by beating up on people. Okay.
Hold on, not all of us.
All right.
I'm not speaking for Bill.
All right. What's up, Minaj?
So when I pulled
Wait, that was recorded. Oops. Okay.
pulled gender and age out,
Yeah?
and it gives me the question, why would it do that?
You pulled out gender and age and it gives you a question.
Yeah,
Label.
just as it's a label.
Put your label.
Oh, yeah.
I went back into SPSS and cleared that.
Yep.
label.
Or you can go like this. Double click it, go to the text, and just delete the label.
Yep.
Yeah. There you go.
When you
Okay.
co-vary, do you co-vary those then? Because like age
Ah.
and education are probably related.
Yes, I would covary age and education because they are definitely related. Do I covary gender and age? That makes no sense. Or gender and education? No. BYU, actually, I collected this data at BYU, and females tend to be younger than males at BYU because men go on missions when they're 18 or 19, and so men come back after the mission 2 years later and take school. So men tend to be 2 years older than women at BYU. So there might actually be some relationship at BYU because of the context of our sample. There might be some relationship there. We'll find out. Modification indices will tell us. Okay, do I covary gender with anything else? Ladies, will you tell me? I'm really bad at this.
It must be happening.
Is there any relationship that you can theorize about generally, not specifically, generally about gender? I'm seeing shakes of the head. Men and women mostly the same on all this stuff. Thank you. Okay, age. Playfulness? I think maybe age on a few of these things. These three. Education, I think definitely. These are all double arrows, yeah. What a mess, isn't it?
Yeah.
What about age on joy and usefulness? Education on joy and usefulness? Maybe education on usefulness? This is totally subjective. But you do need to say where you controlled and why. It's just one paragraph. We controlled for these things because, and this is where we controlled for them.
Doesn't that add a lot of complexity, though?
It does.
Why would you, at least you do what makes sense, right?
Well, you do what makes sense, or you could just go look at the modification indices and let the statistics dictate it.
So explain with references?
With references, I don't know if you need any references for this. It's more logic than references for controls. Yeah.
Within the model, I mean,
If you go just on your DV,
Uh-huh.
does that kind of control everything?
No, you're only controlling for age on the effect it has for system success. Yeah.
Can I ask you another question?
Oh, please.
Just throwing all these covariances in.
All of them? Just do all of them?
Yeah.
It's atheoretical. But Amos assumes that all exogenous variables are covaried. So there's an argument for both.
Right, these are controls. If the covariances are 0,
We don't care, right? It is adding complexity, decreasing degrees of freedom. That's one reason I tend to not do it. With the IVs, I always just covary all those because Amos assumes that they're covaried.
So another way, this is what you were saying, I guess, not put the control covariances and look at modification indices.
Yeah, if there's one that the statistics say, hey, you should have done this, go ahead and add that because it's a control and who really cares? Yeah.
James?
Hmm.
So Mike says that it seems that James can still not hear us.
Are you guys talking?
Should we check the chat more often?
Yeah, here we go. To moderate by a categorical, does it have to be, oh, thank you, Linda. Yes, to moderate by a categorical variable, then, does it have to be binary variable? That's jumping ahead a little bit. To control for a categorical variable, it needs to be binary. To moderate, that's a different story. We'll talk about that in a little bit. But gender is useful because it's binary. Let's say we were controlling for industry. That wouldn't work. We couldn't just throw industry in there. We'd have to create what's called dummy variables in order to do that. And I haven't taught about dummy variables, but essentially what you do is you create binaries for each potential value. So if you have retail, service, and manufacturing, you'd have a retail dummy of 0 and 1, and if you are in retail, you get a 1. If you're not in retail, you get a 0. If you're service, you have a service, or there's a service dummy, binary, same thing, and there's a manufacturing binary, and then you might have an other, right, if you're not any of those three industries. If you don't have an other, you actually would drop one of the three binaries. You have as many binaries as values you have, minus 1. So if we had 3 industries, we'd have 2 dummy variables. How on earth does that work? It's magic to me. The two that you do include use the third unrepresented industry as a reference point, and all effects from those dummies are then relative to that reference point, which makes absolutely no sense to me at all, and how it figures that out. If one of you knows, I'd love to be enlightened. Darn. Well, let me know. Because it really is like magic. So that's how you do that. Just create a bunch of binaries for each value. Let's see. How do we know if the variable is endogenous or not? Good question. It's endogenous if it has a regression arrow, a single-headed arrow going into it. If it's being predicted, it's endogenous. If it is not being predicted, it's exogenous. If it has arrows going in and out of it, it's endogenous. Endogeneity trumps exogeneity. Yeah. There we go.
Endogenous means it comes in and out.
No, endogenous means it's being predicted. Yeah. But you could think arrow going in.
Yeah, endogenous is internal, exogenous is outside.
Yeah. Except that you could have an arrow going in and out, and then what? It's endogenous. Yeah. Okay. Thanks. Sorry I can't hear you guys at all on that side. Hey, Mike, I'm going to try to unmute you. I wonder if it muted you. See, it doesn't say you're muted. Wait, okay, Mike, can you talk?
You shut it off.
You're talking now. Oh, it turned you back down. Now talk.
Can you hear me now?
Holy shnikes. Yes. Sorry.
Excellent.
That was really loud. Like the voice of God. Okay, here we go. Wow. All right, now I'll be able to hear you. Ha! I had to unmute you, though. Go ahead and mute yourself, and then unmute yourself when you need to talk, I guess. Can I unmute Linda? Unmuted? I can't unmute you. You have to unmute yourself, I suppose. Okay. Cool. All right. Yeah, she unmuted herself that time. Good. All right.
They have just industry services manufactured. Can I control without doing a dummy variable?
If you only have 2 industries, yes. It's one or the other. But if you have 3 or 4, then no. Nadia, no, I can't hear you. You have to unmute yourself.
Do I need to make a multi-group metarator in this, multi-group control?
There is, you have to make multiple dummy variables for a polynomial variable like industry or ethnicity or nationality. If it's not binary, you have to make dummies for it if you're going to try to regress with it.
Okay.
Yeah. Yeah, I can hear you, Nadia. So what do I usually do with controls that are polynomial? I avoid them, if at all possible. Just avoid them. It's like formative factors. Just if you can, avoid them, and they make your life much more difficult than it needs to be. But if you're doing a study on firm performance and you're collecting across multiple industries, obviously you need to control for industry. So
yes.
Do it. Okay. Where were we? We just controlled for stuff. Now let's go ahead and set up our structural model. Yes, let's go like this. Just draw our arrows. Boop-a-doo. Do it systematically so you don't forget anything. Now, right now we're setting up with a full model, right, with mediators present. And I'm even going to draw in the direct effect from independent variable to dependent variable. It gets really messy. It's not pretty like our model here. It's really messy, which is fine. It doesn't need to be pretty. When you report the model in your paper, you don't copy and paste your Amos model typically. You go create a PowerPoint model or a Visio model. Okay. What are we missing? We don't want unobserved variables. We need error, which I guess are unobserved. So you're technically correct. If you had an interaction, you mean? Or like a multi-group moderator? Multi-group moderators are not present physically, visibly in the model. We'll cover those in just a sec. Mediation first. We're going to name those with plugins, name unobserved. Names them automatically, which is nice. And I'm going to save this before I forget. As SEM Mediation. excuse me, some analysis properties. What do we want? Standardized estimates, squared multiple correlations, that's the R squared. Modification indices, I'm just curious. And indirect, direct, and total effects. That's going to give us the indirect effect. Okay. So what we're going to do, we're going to test for mediation. We're going to test with the mediator first and then without the mediator, which sounds backwards, but it's already built with the mediator, so why not? And then we'll delete the mediators and test it without the mediator. Now we have a bit of a tricky scenario here. We have two mediators. So any indirect effect is actually occurring through both. Any effect playfulness has on system success is occurring both through usefulness and through joy. So which one is mediating it? Don't know. Hard to tell. So what we can do is remove, when we're testing for mediation from playfulness, we could remove the effect from playfulness to joy and just test the mediation through usefulness. And then when we're testing from through joy, remove it through usefulness.
Are you testing your model fit right now?
Not yet, but we can. Woo.
Because if it's a poor model fit right now, I'm just gonna fix it.
Fiddle with it a bit?
Yeah.
Probably should. Yeah, when do we report model fit? Because we're going to test mediation, moderation, interactions. When do we report it? I would report it for the mediated model. Anytime I have a complete model, I'd report in just one line or two the model fit.
You need to use all of them, or do you just
CMIN or BF was this, CFI was this, we're good.
yeah, or you're bad.
Or we're bad, and so we figure, well, no, you'd get it good if you could. Yeah, if you were bad, you'd have to then say, but we didn't achieve good model fit, so limitation.
Or you get rid of a variable.
Yeah, you could try to fix it that way.
And it's all right to go and, let's say joy doesn't work out, or usefulness doesn't work out, you go in there.
Yeah, say we could not obtain good model fit with those variables present, so we lopped them off.
I found bifurcation with all rows in 2002.
Oh, yeah.
But I'm not comfortable sharing it with the class yet until you look at it and see.
Okay,
if
yeah,
it's
email it
fixed.
to me. I'd like to see if it's what I'm talking about.
Yeah.
Thanks. I don't know if that's the right word even. So.
He uses bifurcation, but he uses it a little differently.
Okay.
But it describes your intent.
Oh, good. Okay. Is your question?
Yeah, question. If you want to measure the direct for the IVs could I have started by not using the mediators?
Oh yeah, I'm just doing it backwards. I'm doing with mediators first. Yeah. We'll do both. Okay. Another route is to just have one mediator in here at a time. And then, see, but the problem with that is you need to report the full model. Yeah, I just dropped one arrow at a time. Okay. Here we go. Or you could theorize about net effects, the extent to which both mediate simultaneously. But you'd have to theorize that way when you set up your hypotheses. If you theorize about them separately and then test them jointly, you're not testing your hypotheses. Okay. So let's test some mediation. We're going to write down a bunch of numbers. I'm going to create a table here. Let's just go to Word. Insert a table of certain size. And this is, see, path, direct, without mediator, direct, with mediator, indirect, indirect effect. And maybe add another column for conclusion. Insert column to the right. Conclusion. Let's stick in a few. So we have playfulness to system success. Play to system success. Comp to system success. Oh, but it has to be through something, right? Let's do through joy. through usefulness, just to change it up a bit. And we'll do one more. A tip through joy. So just setting things up so I can write some notes so I'll know for sure what the effects are and what the mediation is. I'll leave this up for a sec so you can sort of copy.
Do we want to have any arrows between things like usefulness and joy?
We didn't theorize about that, not in our original model. The question for the remote folks was, do we want a line between the mediators or between the if we have multiple dependent variables, maybe between the dependent variables? If you theorized about it, yes. If you didn't theorize about it, no. If the modification indices say you really ought to, then that's an executive decision you need to make. Another alternative is if they are highly similar, sort of like our information quality and decision quality, you might just covary their errors. And so you're accounting for their similarity without explicitly theorizing about them. Is that cheating? I don't know. I don't think so. Okay. Got that up. So let's go find the direct with the mediator, the direct effect with the mediator. This is play, joy, system satisfaction. Play, joy, system, it's success. Yeah, okay. In order to do that, we have to get rid of the play to usefulness. Otherwise, it's multiple mediation. Let's run this. Proceed. And what we're looking for is this direct effect, standardized direct effect. 0.14 is what we've got. And is it significant? Let's go look at our output estimates in the regression weights table. We're looking for play to system success, which is significant, 0.0023.
James, so if we had two dependent variables, we would also delete the path to the other dependent variable from joy?
No. Good question. Yeah, if we had the two dependent variables here, the indirect effect from play to one of them is only happening through one of the mediators, unless the two DVs are connected somehow. If the two DVs are not connected, no, you don't have to change anything.
Okay, so I'll only delete the path to the other
Mediator. Yeah, so there's only one A to M, M to, or X to M, M to Z, X, Y. You know what I'm saying, right? There's only one triangle going on. Okay.
For mediation, if we don't have a direct significant effect?
If you don't have a direct significant effect, like this 0.14 here,
Yeah.
you make note of it. So let's make note of this.
No, I meant if we don't have a direct significant effect between, for example, playful and system success, can we still test for mediation?
Yes. Yes, we
cannot assume mediation if there is no significant direct relationship between the dependent and independent.
Right. Where'd that table go? Here. Notice for these two, without the mediator, no significant effect. Direct significant effect. With the mediator, no direct significant effect. So yes, we can still theorize about mediation. It's only when we don't have X to M and M to Y.
Okay.
Yeah, let's say play to joy was not significant, then we could not theorize about it. Or joy to system success, then we could not theorize about it.
Okay.
Or we could theorize, we just wouldn't have evidence to support our theorizing. Cool. All right. So it was 0.14, 0.14. Yes?
James?
Yes?
Can I follow up on that question?
Yes.
If you have an if you have an insignificant direct effect and yet you still test for the mediator, can you assume that the mediator is somehow canceling out the effect of the independent on the dependent or something like that?
Typically, You said if you had a non-significant direct effect originally, like in one of these two.
No, I think I said that. I think
Backwards?
I said that, but I think I meant the opposite.
Okay, so if you had a significant direct effect without the mediator, and then you add the mediator and all of a sudden it drops or it's completely non-significant, can you assume that the mediator is just swamping out the effect? The answer is that's sort of what it's doing. Assuming the x to m relationship is significant, then we're assuming that effect is occurring through the mediator. That's what's happening, yeah.
James, can you go back and show where you're getting information from?
Oh yeah. So where did I get the 0.14? From right here, the standardized direct effect from playfulness to the dependent variable. And then in the output, in the estimates regression weights table, we look for playfulness on system success, which is right here. Why it's left to right, I mean right to left, makes no sense to me. The guys who made this weren't even European. Or no, is that right? Yeah. Okay. Asian. Thank you. Well, you can't say it depends on the anyway. You know what I'm saying? And then here's the p-value right here. 0.0023 is less than 0.01. So we have a 99% confidence there.
Shouldn't we be able to see the 0.14 somewhere in the text?
Yeah, it's over here in standardized regression weights. 0.1390, which is 0.14. And typically we would report the 3 decimals, so let's do 0.139.
So, playful direct system success. Well, we're doing direct with a mediator, right?
Direct with mediators. Still significant. So what's our potential right now?
Okay.
The only thing we could observe at this point is either partial mediation or bifurcated mediation. Could only be partial or bifurcated.
Somehow I've got a different number.
That's fine. Okay. Now let's go do the other two. Comprehensiveness of use. That means to how much of the system you're using to system success. Let's go. We have to do though, add back in play to useful, get rid of comp to, this is through use, so comp to joy.
You don't need to, the DC to, and the usefulness to the system success at that point, you don't have to report that either?
No, we should see if they're significant probably, huh? Just make note of it. I should have done that, but I did notice that they were significant.
If the level of significance doesn't matter, how much it's
Nah. Question is, let me interpret for everybody. Should we have checked play to joy and joy to system success? See if those two paths were significant. Yes, we should have, and I did. I just didn't say anything. They were significant and substantial. And they need to be in order to claim any sort of mediation. We'll run it again, I'll show you. Here. So 0.59 and 0.26, both significant is my guess, right here. Play to joy, significant, yeah. And joy to success, significant. And now we're looking at comp to success, not significant. And the effect is negative 0.0348, but negative 0.035 essentially, and they changes back to 3 decimals. There you go, negative 0.035. Have I lost anybody?
Yeah.
Okay, 0.035, negative, and not significant. Oh, don't worry about it. Okay, you're probably not the only one who's lost. What I've done, so I'm just going through with the mediator. Since we have 2 mediators, this is kind of complex. I'm going through and finding the direct effect from IV to DV for each of these paths. I just selected a few of them. If you were doing this for your model, you'd do it for all of them. I'm just doing this for illustrative purposes, just doing a few of them. But I'm finding out what is that direct effect between the IV and the DV. In this case, play to success, comp to success.
Just make sure I can
And then I'm
the 1-3, right? Under the
This one?
There. That's the direct effect with the mediator.
Yes, for this first one. It was actually 0.14 for me, but I got rid of this path, play to useful, play to joy, I got rid of. Or whichever one, play to useful. Yeah, play to useful I got rid of, which bumped this up. So some of the variance that was being explained through usefulness is now being explained directly.
Okay, that was in the previous one.
Yeah. Yes.
If I go to model output and choose indirect and authoritative, whatever
Yes.
choice, then what will be the impact?
We should be doing that, bother. We need to be collecting this at the same time. Oh, thank you. Let's do it. Okay.
James, I have a question. So
Yes.
if you're playful and you're going useful and you have two DBs, can you do the two at the same time without changing your arrows?
Yes, you may, unless they are somehow connected with a regression line. Because there's still only one direct or indirect effect to the DB you're theorizing about.
Okay, so play for usefulness and then DB1, and then play for usefulness DB2. The only thing you have to delete is the play through the joy.
Yes. So there's only one indirect effect to each DB. Yeah. When you're testing that indirect effect. Okay, we were supposed to be doing bootstrapping and finding the indirect effect. So sorry we missed that, but that would have been a lot altogether anyway. So in the analysis properties, you go to the bootstrap and say, yes, please perform bootstrap. And not just 200, do 500. Unless you have a really slow machine, then do 200. And I'm going to use bias corrected confidence intervals. Why? Because it handles error better. Bootstrapping will sometimes inflate estimates, and so this corrects for that.
95%
Use
or 90%?
95.
Sure, 95 is fine. There we go.
And make sure you check indirect.
Yeah, and make sure in your output the indirect total indirect effects are checked. Yeah, sorry, that's really loud.
Can you show the bootstrap again?
Yeah, bootstrap, perform the bootstrap and do bias corrected confidence intervals. I've been directed that 95% is what we want to look at.
You have indirect.
Yes. I always use 90. Okay. And close and run. This will take longer to run for some of us. Okay. This time I'm checking this second one. I need to go back and do this first one, but I'm checking this second one, comp to SS. My output came out down here. Okay, the bootstrap results are in a nice hidden place. We're going to go to matrices, standardized indirect effects. Here is the effect from, I'm looking for comp to system success. It's 0.12. So let me throw that in there, 0.12. Over here on indirect effect, 0.12. And then the p-value for that is hidden down here. If you go down here in this little menu and open the very bottom, comp to system success is actually very significant. You think 0.12, how is that significant? Well, indirect effects tend to be small yet impactful. So yes, it is significant. That is star. Not less than 0.001, but it is less than 0.01. So that's a p-value. Seems complicated, right? Yes, it is.
Can you go back to the
Huh?
bootstrap estimate table and
To-
how to read that again?
The estimates table. So I was looking at the comprehensive use, this column, indirect effect on system success, which where the intersect is that effect, 0.12. 0. Okay, let's go get it for play to SS, because I forgot to do that. And that's through joy. So let me add back in the path from comp use to joy. Get rid of the effect from play to usefulness, because we need to redo this one. Run it again. Hopefully having this video will help you as a review if you need. And I'll just go grab those values again. Estimates, matrices, standardized indirect effect from play to success, 0.149. 0.149, which is significant. If we go down here, it is play to success 003, significant. Star star. Okay, so at this point, we know that there is probably some mediation going on because we have a significant indirect effect. We just don't know what type yet. Let's go do the last one. Atypical use to satisfaction through joy, or success through joy. Add back in the path we removed. Get rid of atypical to useful. Run it. Get the direct effect. Which is atypical to system success right here. Whoop. 0.063, definitely not significant. Oh, at the 90% confidence level it is actually. Wow, I'm surprised. That p-value 0.098.
What are you getting at significance in direct effect again?
I'll show you. So this had a p-value of 0.098. Significant or not? Not at the 95% confidence level. But yes, at the 90% confidence level. Yeah, whatever you set it at. So what I would do here is maybe put the exact p-value in here. P equals 0.098. So just show, I mean, that's pretty darn close. But you know what? This is a really small effect. So you know what? At this point, not significant. If this were like a 0.263 and it was not significant at 0.098, I put the 0.098 in there. But this is so practically meaningless that we can just get rid of it. Okay.
James?
And to answer your question, one more thing real quick. Somebody asked here, where do we get those values for the indirect effect? It's estimates, matrices, standardized indirect effects. And then there's this matrix, and we were looking at atypical use to system success, negative 0.014, probably not significant, 0.014, oh, negative. Let's find out if it's significant. Bootstrap, bias corrected, two-tailed, and it is not significant. That's greater than 0.05 or 0.1, so not significant. At this point, is it possible for us to have mediation from atypical use through joy to system success? No, because this is not significant. So I can just write now, no mediation. I still want to find out what these values are, though. Okay, who had the question remotely? Go ahead.
For the effect with the mediator, I didn't see you being quick. Are you looking at the regression table or the standardized?
Both. So if I go to the scalars here, we look at the standardized regression weight table to find the standardized effect, like 0.063. And then we look at the regression weight table to find the p-value. Don't you wish they just stick the p-value down on the standardized regression weights? Wouldn't that be nice?
Easier.
Yeah, it would. Yeah. All right.
Standardize everything beforehand.
That'd be great. Oh, well then you just use, same table. That's not a bad idea. All right. Okay. Next, we need to do all of this without the mediator. So, save, file, save as, SEM mediation, no mediator. Something like that. And now you just kill the mediators. Adios. And run it. And we're just looking at direct effects now. So run it, proceed, up arrow, and let's look at the output. Estimates. Here we go. From play is 0.426, 0.114, 0.071. Is that the right order? 0.426, was it? Yeah. And 114071. No, 114, whoops. Okay. Okay. And are they significant? Yes, yes, no. 3 stars, 1 star, no star.
Is that a 2-star? Under 0.5?
Under 0.05. Depends on where we're setting our threshold. I've been giving 2 stars to less than 0.01, but not less than 0.001. Yeah. And you should make a note of that down here. You know, note. Star, star, star. Is P is less than 0.001. Oh, thank you. Something like that. Okay. So you tell me.
Just show me what the Amos model output.
Show you the Amos model output?
No, how do you draw it, no mediation?
Oh, like that? I just deleted the mediators. That's all. Okay, so you tell me. This one. What type of mediation do we have?
Partial.
It is partial. Why?
Both is direct.
But look at the drop. Huge drop. It was just powerful. And then it dropped. Still significant, but the effect dropped. That means that a lot of the variance that the IV play was explaining in the DV, system success, is actually being explained through joy. Good. This one. Full mediation. Because it was significant, albeit weak. It was significant, but after adding the mediator, not significant. So the effect comprehensiveness of use has on system success is explained completely through the amount of usefulness you derive from using it comprehensively. If using it comprehensively just leads you like on a wild goose chase and it's not useful, well then there's no success. So it's fully explained through whether that was a useful endeavor. Yeah.
If you had an example, which you don't have up here, that is a Hayes example of indirect effects only. Would you
Yes.
mind talking about that a bit?
Oh, definitely. Yeah, so like we had here, this one, where you have no direct before or after, but there is a significant, by some miracle, there's a significant indirect effect. And we talked about that sort of like trailer parks and tornadoes. I mean, there's something there, we just can't explain it. Yeah.
The effect has to be, from X to M, has to be significant.
Always. X to M and M to Y have to be significant at all times. Yeah, or else there's no mediation going on. Let's take a quick break unless there are final questions on mediation. Yes?
I didn't catch what the bootstrapping did for us.
Bootstrapping created this for us. Good estimates matrices. These matrices are created, well, no, I guess the bootstrapping here, the estimate bootstraps are created when we bootstrap. We're able to obtain a p-value for the indirect effect when we run a bootstrap. I haven't actually selected anything, so I don't, that's bizarre. Oh, we're not running any indirect effects on the unmediated model. Huh. That's why that didn't show up. But that's what it gets us. It gets us the p-value for indirect effects and total effects.
Indirect effects
Without a p-value.
We need a p-value.
Yeah. Any other questions before we take a break?
James?
Yes?
Do we look at the between the relationship between joy and system success and usefulness and system success? Do we look at that value?
Yes, you need to make sure those are significant. If they're not significant, then you'll have no mediation.
Okay.
Okay. All right, let's take a break. Come back here in at like 10 till or something. I always say quarter till, and then we always start at like 5 till, so figured meet you halfway.
I sometimes just have trouble seeing physically.
All right, we're back on. A couple additional things that we discovered during the break. The first thing is, if you would like the lower bound and upper bound confidence intervals for that indirect effect, Amos produces those for you. It's right here on the left. Instead of going to the two-tailed significance, which is also useful, you can see the lower bound, indirect effect. If I've selected standardized indirect effect up here. Here's the lower bound. So like for play to system success, it's 0.249. There's a 95% confidence interval, lower bound. And here's the upper bound, 406. And then the actual effect, if I just click on estimates, is 318, which should fall in between those lower and upper bound. Also, there's research that shows that bootstrapping inflates the estimates. I mentioned that briefly, but we're correcting for that with the bias-corrected intervals. It says here bias-corrected percentile method, so that deflates that inflation. So we're good on that point.
You should say about that in your write-up.
We used bias-corrected bootstrapping. Yeah. Another thing, though, I discussed bifurcation, but I missed a piece of bifurcation. Somebody brought up. What if this funny thing happens where you have, in fact, let me just add can I tab? Yeah. Let me add a row here. So sensitive. There we go. Okay. Bifurcation B or something like that. Where that's too big. Gonzo. I get to name this stuff, so here we go. Where without the mediator, you have nothing. With the mediator, the direct effect is significant, but the indirect effect is not. What is this? Because this also happens. This is a form of bifurcation that is not mediation. The mediator has sucked away some of the variance, either the positive or the negative effect, and leaving the stronger effect to directly affect the dependent variable. So now this effect is significant, and this one is not. It was the weaker of the two divergent effects. It happens. What do you call it? An interesting finding. Or gonzo. I think gonzo's a really good name for it. We had a gonzo effect. I can't wait to see that in print. It happens. I have seen it before, and somebody, maybe it was Ronnie, I can't remember who mentioned remotely. But yeah, it happens. What do you do in that case? Say exactly what you found. Say we added the mediator, and apparently there was a dual effect, a weak effect, and a dominant effect that were clouding up, or, neutralizing each other without the mediator. The mediator helped bifurcate those effects, allowing the stronger effect to come through. Yeah, just say it exactly how it is. We had a DM student who had that as well. I can't remember which one it was. Anyway, does that clarify whoever asked that question? Yes. Oh, good. Steven said I have it in my data. Yeah. Okay. Thank you. Yeah?
I mean, you had a layout of hypothesis with GFI. Can you show it?
The GFI?
No, you had a whole text was from with the hypothesis statement.
Hypothesis. This?
No.
To what are you referring? What concept are we on?
It was not a concept, it was probably an output, a Word document. It was shown to someone.
Are we talking about mediation?
It was a document, just when I came in.
You saw a document up when you came in.
Today? This one, yes.
Yes? I was just reading because I was bored. No, this is the thing Lori sent me about bifurcation. I just didn't get through it. Too many questions. So I'll read through it.
You sent it to it?
Not yet. I need to read through it, make sure this is what I was talking about.
Yeah, I'm not entirely sure that it is, but it is,
Sounds right.
it's interesting.
Okay. Here we go. That's mediation. So we figured it out.
James?
Yes?
Just a question. If the estimate between joyful and system success was negative, will you still check for mediation?
Oh boy, that's an interesting one. Yeah, so what if you have from the IV, let's get the PowerPoint up here. What if the X to M is positive and the M to Y is negative? Well, what then? You look at the indirect effect itself. So over here we saw we had a positive indirect effect. Therefore we have positive mediation. Here we had negative, but it wasn't significant. Let's pretend this was significant. This would have been a negative mediation. That's what you call it.
James, can you talk about writing the hypothesis with this? Because
Sure.
I know if you write every single one separately,
Oops.
a lot. So give some advice on that.
Like for this model here, how many what kind of hypotheses would you write? Good question. I would do something like this. H1A. Should I zoom in a bit? There we go. Whoa. H1A is usefulness. Oh, bother. Whee. Okay, usefulness mediates the positive relationship between playfulness and decision quality. H1B. Usefulness mediates the positive relationship between playfulness. I should have copied and pasted, huh? And information acquisition. I'd cluster them a bit. Yeah. Or you could do it like this. Usefulness, H1A, mediates this, this, and this, H1A, B, and C. Using usefulness as the driver.
So you could say, how would you say that then if you're going to cluster them together?
H1A is this, this right here. H1B would be the exact same thing, but I'd change playfulness to comp use. H1C would be the same thing, but I'd change comp use to atypical use.
So you're using usefulness. Your mediator is then like hypothesis 1 would be all the implications.
All the usefulness to decision quality ones.
Okay, so then you would cluster them together, and then when you report out on the results, you would say my hypothesis was usefulness mediates these relationships.
And then show the evidence, yeah. But I wouldn't do H1, H2, H3 and have like 30 hypotheses. Really we do, but this makes it feel less. Yeah, it's less cognitively taxing. Bernie, you had a question.
So I think you're jumping the gun, but not hypothesizing, theorizing about your moderators.
Oh yeah, not yet, yeah. We'll theorize about moderators later.
If you have positive and negative, how you will express it?
Well, instead of, like positive on this path and then negative on this path?
Yeah, like if you have playfulness to usefulness was positive and then from usefulness to information was negative.
You'd say something like usefulness negatively mediates the positive relationship. Sounds funny, but it's getting really specific. Or you might just do this. Get rid of that and get rid of that. and then in the findings say what it was and say how that was interesting.
You could say mediate such that the relationship between playfulness and usefulness is positive, but usefulness and info acquisition is negative.
And that gets really complicated. Yeah.
Can I ask something?
Yes.
So later on, we're going to be doing last thing. I know we're going to be doing interaction.
Yes.
Because we're going to be doing an interaction, wouldn't it be useful to have direct association hypotheses between playfulness and usefulness? The set on the left and the mediators, because then you could say the interactions actually.
We do, don't we? From here to here?
Yeah.
We do. I didn't understand the question for sure. We have direct effect here.
I guess I was just confused because you called the mediators H1. I mean, in reality, they would be.
Oh, no. No, H1 isn't the mediators. I'm saying, when you're mediating, you don't have to hypothesize direct effects unless you really want to. They're subsumed in the mediation, and you're testing for them as you mediate anyway.
So you could have a set of hypotheses. If, let's say, this was your model, you could have no hypotheses that ever say playfulness has
A positive effect on usefulness, or a positive effect on information acquisition. Don't need them. They are implied in your mediation hypothesis. Yeah, because theoretically, this is what we're testing. When we're statistically, we're testing this, but theoretically, we're testing mediation. Yes.
Since you are moderating the later on, your hypothesis would be, shouldn't be a more.
No, should it be gender moderates the mediated relationship between? No, you can. Don't. I just wrote a paper with a good person, friend, DM student, who she said, so I can get this wrapped up in my head. Well, she had our model, interactions, multi-group moderators, controls, and mediation, and threw it all into a single hypothesis. So it was moderated, mediated interaction with controls. And she theorized about it. It blew my mind. Like, turned it in knots. Tied it in knots. It was amazing. I'm just not that smart. I can't handle that. All right. Moving forward.
James?
Yes?
James?
Yes?
Just a comment. Does this have to do with parsimony, that we only address the critical paths that we're examining against our theory as opposed to the underlying
Yes.
fully connected model?
Yes, if we were to write a hypothesis for every line and every indirect effect, we would have 60 hypotheses and our paper would be 120 pages long, and we might as well get a PhD for it because it's a dissertation, right? Okay. One more question. Andreas.
Would you put a hypothesis as an interaction on a mediator?
Yes. You're asking if I threw in an interaction here and regressed it upon the mediator, could that regression line essentially be a hypothesis? Yes, and we will. We'll get to that. Okay. Good. Moving forward. Not moving forward. No, I don't want to move forward unless you understand.
Well, I know we're going to get into interactions, but we don't hypothesize it. You've heard you don't hypothesize interactions.
Maybe misunderstood.
So you can't hypothesize an interaction.
Oh yeah, it's just the way you do it. Yeah, I'll show you the way. Okay. Okay. We're good?
James?
Yeah?
Sorry. Why in the slides you don't have a direct link between playfulness and information acquisition, and in Amos you have?
Is our conceptual model. So conceptually we're saying there's just mediation going on. But in order to test this mediation, we have to add these direct effects. But this is what we're theorizing right here.
But later on, are you gonna keep it?
Here, keep these.
No, I mean, are you gonna keep the direct effect later on, or you're
Yes,
gonna
I will.
remove
Yes, I'll keep those direct effects.
it? Okay.
I have just cause, to delete non-significant direct effects if I please, if I'm running into a barrier of 0 degrees of freedom. But if not, I can keep them. Different schools of thought on that, actually. So either approach is fine at this point. Okay, moving on. For real. That's mediation. Boom. Mediation is probably the most complicated concept in SEM. So if you can get that, if you can think through it logically, set up support for your hypotheses for that, and test it, you are an SEM ninja.
James, question about arguing or supporting your hypotheses in
Uh-huh.
your theory section. Because you said if you've got a mediator and you've got some effect, you don't just say, well, there's effect from here to here, it's like a throughput effect.
Yes.
But aren't you supposed to start arguing about this link to this link to that?
Those links do have to exist.
Can you
What you need to rely on, so supporting your hypotheses for mediation, you need to support an X to M, M to Y relationship. But it can't just be that. And there also has to be an X to Y relationship, right? It can't just be that. It has to be, rely on this thought that the mediator is the reason there is an effect. It's the carrier, it's the transferer of that effect. It's not just X to Y, or X to M, M to Y. It's because, let's do one real quick. It'll help. Let's go back to this one here. Curiosity, discovery to system satisfaction. Curiosity, impact, it has a positive effect on system satisfaction. The more curious you are, the more satisfied you're going to be. There's this affective response when you're curious, and it's a satisfying one. There is an X to Y relationship there. But in so much as curiosity creates a need to discover, which is satisfied, and discovery leads to satisfaction, that effect between curiosity and satisfaction is carried through that discovery. It's as curiosity creates this desire to discover that you satisfy, that it becomes satisfying. So it happens through the mediator. You're welcome. Moderation.
James, can I just say one more thing?
Yes, you may.
Thank you. I don't know if I'm right or not, but could you use the example to differentiate between mediation and moderation that watching TV causes weight gain?
Oh, are you looking ahead in the slides?
Oh no, I didn't. Why, did you have that one?
Check this out. This is amazing.
Oh gosh, I'm either psychic or psychotic. I don't know which it is.
Yeah, they're very similar.
Very similar.
Look at that model on the left. TV time leads to obesity. For real study. Dietz and Gortmacher. 1985. She disappeared.
No, I'm still here. It's just sort of weird to me out that you have that exact example.
How about that? It's not moderation, it's just controls. Okay, what was your question though?
Oh, I just thought it was a good example because obviously TV watching doesn't directly cause weight gain.
Right.
But it's the lack of exercise and
Yeah.
the eating while you're sitting on the couch that causes it. And so...
Yeah, that's a really good example.
Yeah, okay. Well, you're going to do it anyway, so great.
Yeah.
Thanks.
No problem. Okay, moderation. Off of mediation for a bit. Moderation. It's different because this moderator, changes the nature of the effect from IV to DV. That's what it does. Changes the form of that relationship. So autonomy to satisfaction, that's our predicted effect, our main effect. What might be a good moderator there? what would change the nature of that effect? Either weaken it or strengthen it or flip it so it's not positive, it's negative. Change the form of it.
Unclear, John, so unclear role.
Role conflict?
Role conflict.
Role conflict. Yeah, you can have autonomy, but if you don't know what you're supposed to do, all the autonomy in the world is just unguidedness. Right? And it's frustrating, actually. Very good. I like that one.
Trust.
Trust.
If you are a developer working in a cubicle and you're left alone to do your work, you'll be satisfied, but it's rude that effect can be changed by trust. If you have high trust, you're like, I'm satisfied, you trust me to sit there and do my work and get my job done.
But you don't trust me, you're
you
isolating
yeah,
me.
you can isolate someone but not trust them. And if they don't have that trust effect, then
It won't lead
they
to
might
satisfaction. Nice.
Confidence?
Confidence. Yeah. I've had this argument with people before. I very much am of the undirected learning approach. That's my learning style. Just let me tinker and fiddle with it. Give me my autonomy and I'll figure it out. Other people are like, give me a manual and I'll figure it out. Yeah, confident. It's or learning style / confidence, something like that. Yeah. Cool.
Question?
Yes.
If we were to do one like birth order, would we need like another mediator, in there to make it make sense?
No.
So,
If the question marks were birth order, if you were the first child, last child, middle child,
right. So
no, you could actually just throw that in there.
Like, birth order shouldn't be the cause. The cause would be like socialization or boxiness or
okay. What is it about birth order?
But I don't know how you would model.
How would you model that? What you do is get rid of the birth order construct and jump straight to the cause.
Okay.
Yeah. But let's say we did have something that was categorical like that and had multiple values. Let's put industry in here again. You could test this across multiple industries just fine. And I'll show you how 2 slides from now. All right, here's an example. Oh, they're wiggling. Focus leads to learning regardless. When you focus, you learn more. But it totally depends on how much sleep you got last night. For some of this is a very practical example right now. I have an 8-month-old. Yeah. Plus, we're going to Disneyland tomorrow, and so my kids just won't sleep. They just... Anyway, but either way, the more you focus, the more you learn. But it depends on the sleep last night. If you didn't sleep much, so less sleep example, the effect is weak. More sleep example, the effect is strong. So the way we hypothesize about this is sleep positively moderates the relationship. I should say positive relation. Sleep positively moderates the positive relationship between focus and learning. Or we could say sleep strengthens, that's a better way probably, sleep strengthens the positive relationship between focus and learning, implying that a lack of sleep would then weaken it. Okay. 2 different types of moderation, categorical and continuous, or multigroup and interaction. With multigroup, here's how you'd model it. It's like we've been modeling already. Good examples with gender, it's one or the other. A more continuous one would be masculinity. To what extent do you feel masculine versus feminine? And that's a more continuous moderator. You still model it the same way in your conceptual model. The way you actually model it statistically is different though. Statistically, you model a multi-group like this. You run this model and then you run that model with one sample and the other sample. Sort of like we did for the invariance test. In fact, exactly like we did for the invariance test. Whereas with the interaction, you model it statistically by multiplying the independent variable by the moderator and including the moderator and the independent variable and the interaction between them. Sorry, this is sort of in the way, isn't it? I'm going to break that. Okay. And that's how you model them statistically. to test them. And there's an easy way and a hard way. The hard way is very well established in the literature. We like doing things the hard way for some reason. It's also less reliable, so I don't know why we're using it. The hard way is to do a chi-square difference test on each path of your model that you're theorizing moderation. Let's say if you have two groups. So this is for multi-group moderation. If you have two groups, male and female, and you have this path, you run the path for males, and then you constrain males and females to be equal, and you test to see if the model fit changes. Model fit is such an indirect way to assess moderation. Not a great way to do it, but it is the established literature-based way, and I don't do it that way. But I have a tool for it if you want to do it that way, and a video. The easy way is like we did the invariance test. You just do a critical ratios for differences test, which actually creates a z-score directly assessing the moderation, which seems better to me, but I've never seen a paper publish that, so we need to do that. So we're going to do it that way. I have a video for that too, though, so we're good. Okay, let's go test it. Frequency and experience on this model. Blue. Sorry, you can't see it. I always forget. There we go. Okay. So you know how to set this up. And, before we do, first off, what are we moderating? Are we going to do the whole thing? Good. It's not that hard. Certainly could. I would theorize a priori. That's what you're supposed to do anyway, right? Write up some hypotheses. Something like, we're doing frequency and experience. Well, let's look at this. What do we think the amount of experience will change? So the number of years you've used Excel. What effects do we think it will change? Usefulness to system success, that one. So the longer you've used it, the more you perceive it's useful, the more system success you'll derive.
You can justify any of that, right?
You could probably
hypothesize about any of that.
So
Justification of public one later on.
pick a couple and do them. Let's just write one up real quick. Man. Usefulness and system success. Let's do that one real quick. And joy to system success. H1. Useful. No. The moderator is frequency of experience. Excel experience. Excel experience strengthens the positive relationship between usefulness and system success. And I would just copy that. Control C, Control V, make this H2 or H1B or something like that. Between usefulness, between joy and system success. So we're going to test these two hypotheses right here. Yep. Let's do it. So just like before, we double click group number 1 over here. Double click that. Change it to low experience. Low experience. And new high experience. And close. And I'll show you a fun little trick in just a sec. Okay, and then there's this little trick you can do. If you click on title and click somewhere over here, and in the caption that pops up, do either / or / I can't remember which, group, all lowercase. So / group, I think, maybe. Hit OK. Maybe it was / group. There it is, that worked. I have to do it for the other one again though. / group. Cool, high experience, low experience. Nice, I can move it. Now we know which one we're on every time. And then if you copy the model, you have it with it. Okay. Anyone need that again? Yeah, it's if you go click on title, and then it'll bring up a caption thingy. If you click out here, and in the caption, do / group, all lowercase. Yeah, looks like, and this, / group. Okay. There we go. All right, we've done nothing.
Is there a quick way to move away from the high and low if you want to go back to the total data?
Yeah, you can actually just add a third group in here if you want to double click and do new all data.
Okay.
Close. And then there it is, all data. And we'll do it over here too. So when you have to change the data files, load up that data, _C. For all three. And then for the all data one, just don't specify a grouping variable. For the low, let's go ahead and specify that. What do we call that anyway? It's just at the end here. Ah, here it is. High-low experience. That's the one we're using, high-low experience. Same here. Oops, cancel. Grouping variable, high-low experience. And grouping value for the low is 1 for me. High is 2. And get that set up. And then it's super easy from here on out. We're going to zip through this.
Can you just hold on a second? I'm trying to get.
I spoke too soon. Go ahead.
I can't get my field open enough so I can see it.
Oh. Well, get to this point.
I can't tell which we control.
You can open that, yeah, right there. I know it's right there.
Anyone else?
Use the grouping variable 1.
For me, for low it was 1, for 2 it was high. Anyone else? Okay. By the way, moderation is fun and cool. Moderation is an interesting thing you can do. You can take an existing study that's really well established and say, yeah, that's awesome, except that it's not accurate. Look how different it is for this group and this group. So this thing we've been thinking for all this time, yep, fails for this group. For this group, it's even stronger than we thought. That's really interesting. I mean, that changes held assumptions. It's really cool and very practically impactful. Okay. Also could save lives, again, with medical studies. Okay. Hit OK. Save as. SEM moderation experience.
Do you want to pick up the critical ratios there, right?
Yeah, I do want to pick up critical ratios, which we'll do in a sec. Make sure we don't have any missing paths. Should be coming 3 out of each of these. I'm missing the one from when we were doing mediation. I deleted this one by accident. Add that back in. Don't miss any of those paths. Okay. In the analysis properties, we don't need indirect, direct, and total effects anymore unless we're testing moderated mediation, which I hope you're not, because That's just mind-bending. Don't really need modification indices right now. We do want squared multiple correlations and standardized estimates, and we do want critical ratios wherever they went, right here. Critical ratios for differences.
And if you have bootstrap, you probably should uncheck that.
Thank you. Uncheck your bootstrap, because that just adds processing time. Okay, here we go. I'm going to run it. Okay, we theorized about these two paths. Usefulness to system success, joy to system success. Hit the up arrow, standardized estimates. And for all data, we see it's 0.26 and 0.57. Fairly strong effects. With a really good R-square here, 0.61. That's fantastic. If I go to the low, how do they change? Not much at all, actually, yeah. If I go to high, not a huge change, actually. So, are those significant differences? I don't know. We'll have to find out. Let's go find out. Go to your output, go to your estimates and your scalars, and your regression weights table, not standardized regression weights, and copy that table over to the stats tools package. To the group differences table that we used before. Now, if you're using the hybrid model with latent factors, you'll probably have some labels that are missing, like we did in the invariance check. You'll need to delete those rows like we did in the invariance check. So we copied over the one for low experience. We need to click down here on high experience to change these values. Copy, paste, and then go grab the critical ratios table.
James, I can't get past the grouping variable here.
Okay, we'll get to you. I'll come back. So it should look something like that. I'm going to run this and scroll up and then help Chris for a sec. Wow, nothing.
Sorry. When I go to the group value, I get two.
That's because you're using where you at cancel. You somehow created separate data sets for each. Yeah, you created a data set just with one of them. That with the high experience. So like you know, I understand you're missing a lot here. So yeah, you're missing a lot of concepts. Yeah, you're missing a lot of data. See if I can find that data set somewhere. Or maybe you imputed while you were. Maybe imputed while you had multiple groups in the CFA during the invariance test. Yeah. So it created data sets for each of them. That's cool. I didn't know it did that.
All right. Okay, we found nothing. Now, I don't think this is very surprising because of what Johannes was saying yesterday about this not really being a theoretical difference between high and low experience. This is 4.5 years of experience is low. And that's ridiculous. That's not very low. So we might get better results if we look at frequency. Let's go look at frequency. Okay, let's go look at frequency. So nothing for experience. Had we moved this down to 3 years or 2 years, whatever the median was, we might find something more significant.
So can you hypothesize from the beginning there would be no difference and say, hey,
You never hypothesize no difference. If you're hypothesizing no difference, why hypothesize about it at all? Unless every paper that's ever been written said, hey, look, there's a difference. And you say, I don't think so. And you theorize why not. It's a very rare case, but we almost never do it. Yeah. Let me reset. So we didn't find any significant effects here. No stars. So no major differences. Reset. Let's go back and do frequency. I'm going to rename these to low frequency. By the way, you can have as many models up here as you want. Just beware, it's going to create a critical ratios matrix for every group. So be careful. I mean, that could be a massive critical ratios matrix. Okay, and all I have to do is change the data, the grouping variable is all I have to change. Instead of grouping variable with frequency, change it to, experience, change it to frequency.
Okay, you have found critical values already, you don't have to do that.
No, because I do, because the sample has changed. Some who were in this group before and this group before are now switching groups. Because just because you had a high frequency doesn't mean you had high Excel experience as well. Yeah.
But you use the category Google that we have in the database.
Hmm?
You have created, yesterday we did that high frequency, low frequency.
Yeah, we already have the variable there. Yeah. So I'm going to run it. Hope we get something. And the output says estimates, scalars, regression weights. Copy this table. Paste. Go get it for the other group. High. Copy. Paste. Go get those pairwise parameter comparisons. Copy. Paste. And run. Please work. Oh yeah, we have a significant difference. Just one. And it's one of the ones we theorized about. Woo!
Question, when you pick the grouping variable, did you pick the categorical frequency?
Did I what?
Would you go back and pick the grouping variable?
Yeah, sure, yeah. Before I do, just follow up on this. We found one significant difference between low and high frequency in terms of usefulness and system success. What does this mean? That means we have to look at these values first, the estimates. The estimate is, well, we have to look at the standardized estimate. Let's go to the standardized estimates for these guys up here. Look at low frequency. What was it? Usefulness to success. All right. 0.518 for low, 0.614 for high. So, frequency strengthens the positive relationship between usefulness and system success, because the number is higher for the high group. So when you're high, so it strengthens that positive relationship. Back to, you want to look at the grouping variable? Okay. Data grouping variable. I have high and low frequency. I'm using a different data set than the one I gave you guys a week ago. Yeah. Cool? All right. Just for the DM students there. Okay. So, any questions about this? What we found, what it means, what that value means, 3.029.
How do you report that?
How do you report that? Say we did, if your hypothesis was, something like this, except it wasn't Excel experience, it was Excel frequency. This is the one we just found support for right here. When reporting your summary of hypotheses and findings, you'd list this hypothesis, list the evidence. What is the evidence?
Yeah, that's what I'm looking for. Is it the regression weight and the significance?
The standardized regression weight, which isn't in this table. These are unstandardized. We need to make a new tool that does standardized. Yeah, you report the standardized regression weight, their p-values each, or if they're significant, and then the z-score for the difference. This is the z-score for the difference. It needs to be greater than 1.96 absolute value in order to be significant at the 95% confidence level. Yeah.
You say when you report, you have to state the standardized estimates.
Standardized estimates. Always report standardized in the social sciences.
And those are unstandardized.
Yes, these are unstandardized because that's what you get in the regression weights table we looked at.
And is that the same if it's not supported?
If it's not supported, list the evidence and say not supported. Yeah.
Okay, and you get the standardized weights by going back and looking at
This table right here. Oh, well, standardized are here. Yeah.
James?
Yes?
I have two quick questions. I don't know if the answers are quick.
Okay.
One is whether the z-score is significant or not. Doesn't that depend on the sample size?
Yes, the z-score is slightly inflated by sample size. But
okay.
Go ahead.
Go ahead. No, go ahead.
Not tremendously. See, what we're creating here, oh, actually this one isn't inflated by sample size because what we're creating here is a difference between the effects, which, we have two different sample sizes. Yes. Equal sample sizes will produce, okay, let's say we have a, let's say in our samples we have 500 in one group and 500 in the other group. If there is a very small difference, it will be significant. Let's say we have 500 in one group and 30 in the other group. If there's a difference, it probably won't be significant because we have too much error in the small group in order to determine for sure what its distribution really is, or where it lies. And so yes, this is very sensitive to unequal or small sample sizes.
Okay, my other question is, the test that you do, I actually have used it. It's wonderful. Thank you so much.
You're welcome.
I've never been able to figure it out on my own.
Oh, okay.
But I noticed that you're using a t-test, if I'm correct.
It's a z-score. It's just a critical ratio.
Okay. Are there any assumptions about the distribution of the data, like it has to be normal or anything?
I do not know. Let me think.
Because t-tests do, and actually the reason I'm asking this is there's an article by Hensler, and I'll find it and put it up, that is stating that parametric tests for multi-group analysis do require normality.
Right.
And that can create a problem.
So yeah, you
And
could
he
say
has
this assumes normality. Yeah. This is You're probably right. There probably is some assumption we're making here of normality, and it would be affected by normality, where normal data would actually produce better results. This isn't a t-test. It's a similar. I don't know what exactly it's doing. It's a critical ratios test of sorts, which is like a t-test. So we have to go look at that. So the answer is I really don't know.
Does the difference matter if it's not significant overall?
That's a good question too. Linda, are you less unsatisfied? Or no, let's see. I know you're not satisfied with the answer. I don't have a good answer for you. I'm saying yes, we should probably have normal data, and this probably makes that assumption. And no, I can't account for it, and I can't measure it, and so we have to assume it. And so that is an assumption we're making. Is that good enough for now? Because if it's not, I have nothing else for you. I have failed.
James?
I think she left.
Oh,
Just a sec. Bill had. Yeah.
So if you go back to the variables.
Unless this is on the same question. Sorry, Bill. Lori, is this on the same thing? Oh, then please respond. Yes.
I was gonna actually keep it really simple in that, let's say for the sake of proceeding with this, because we've got data sets that are normal in our own individual research, but because this hasn't been published, how do we cite this and describe this?
Oh, yeah. You could cite my video. I've had people cite the video before. And I have a link on the Stat Wiki. I show how to cite the video on the homepage.
I understand how to cite you on the homepage.
Okay. For those who don't, it's right there. Right there. You can cite YouTube videos or the Stats Tools package if you really want to. Okay, Bill asked, what do you do if it's not a significant difference? That's what you're asking?
Significant difference. Okay, so the z-score is 2.097.
Oh, okay.
They're on that chart, right? But then you go back to the variables, and those regression rates are not significant.
Oh, they each are. Oh, okay, yeah. So let's say these p-values weren't significant right here, even though we have a significant difference.
Right. And when you go back to the regression rates.
Yes. Haha. That's tricky. So we know there's a significant difference between them, but the effects themselves are not significant. Means we can't rely on those effects anyway. So does the difference between them mean anything? Not really.
Right.
Yeah. Because we can't rely on those effects. We're not confident those are real effects.
I guess we just write it that way, right?
Yeah. Yeah. But you can also note, but look, these are different to some extent. Actually, that works out better when you have not significant here, but you have a very big difference here, right? When you see one effect was 0.2 and another effect was 0.5, and it wasn't a significant difference, you can say, well, it wasn't statistically significant, but I mean, look at the practical significance here. There's a big difference. So I would go back and eyeball some of these and see what the differences are.
What about looking at the model fit at this point?
Model fit. When do you look at model fit? Again, do that periodically. Every time you have a hypothesis you're testing, or a set of hypotheses you're testing with a completed model, I'd go look at model fit and maybe report it. With one line, C-min over DF, CFI, we're good, hopefully. If not, you might have to address a couple modification indices. Can you, let's go look at it right now. I'm guessing we don't have good model fit.
No, not really.
Model fit. Oh, that's atrocious. Just atrocious. Let me go look at modification indices. I know what it is already. It's probably this, joy and usefulness. The more you enjoy it, the more useful you perceive it to be. Let's go figure it out.
Oh, so they capture a lot of the same?
No, they're just, they're similar.
They move together?
They move together.
Yeah.
There's maybe a causal relationship even.
Well, isn't that sort of the issue with mediators anyway?
E1 and E2.
Yep.
Okay, joy and usefulness. So, what do? We can add, okay, this makes things very complicated. If you add a regression between joy and usefulness, what's going to happen to the rest of the model? It all shifts. All the effects are now going also through that path. And, okay, so this is a really sticky scenario. Do you add it, because the model says you should add it and you need to account for the major variance, because if you don't, you can't rely on all the other effects you are observing? Or do you covary the errors, avoid that additional indirect path, but still account for the variance? Executive decision on your behalf, on your part. What would I do? Not that you asked, but I'm going to say. If these were, if I think to myself, I'm taking this survey, if they ask me if I enjoy something, am I also gonna think it's useful? Or if I think it's useful, I'm gonna enjoy it more. Are they moving together? I'd say I could probably covary them. Dave Kenny's site also talks about that a bit. If you can't, but it's such a sticky situation. Because if I add this arrow, I now have all these indirect effects I never theorized about. But I have better model fit.
What about covariating just the error types?
And that's the other option. You covary the error term, your theory stays intact, but the question is your theory still good? Can we rely on your theory? Because you don't account for that major regression.
Isn't that essentially the same?
We are accounting, so now we're controlling for what we are theorizing as a systematic correlation between the two mediators. We are controlling for its variance, and so all effects will be adjusted for that.
How do you describe that again, that when you covary your errors for your mediators?
We're accounting for systematic covariance between the two constructs without, it's really between the two constructs, error, but without explicitly theorizing about their relationship. And we do that so that we aren't adding another indirect effect that we never theorized about.
We're accounting for error.
We're accounting for the correlation in the residual, in the error.
We're accounting, could you repeat the sentence?
Word for word, I'm just making stuff up off the fly. So you write whatever you want. But you're accounting for the systematic correlation or covariance between the errors of these two endogenous variables.
You just get rid of one.
Or you could just drop one, but that destroys your theory. Or you could create another second order factor if they really belong together. Or you could covary their error terms and account for their variance without explicitly theorizing about it. And then hope Dave Kenny's website justifies you.
So I'll run this and see what.
Yeah, run and see what happens. Now when we do this, does everything change? This effect is still strong, about the same, still the same, still the same. Well, still the same. Still the same, same. These effects dropped a little bit actually. 0.11, I think it was a little higher. But most of these effects didn't change much at all. So that's good. We go look at model fit, which is what we were addressing in the first place. Model fit, 947. Pretty good for a composite model with 350 respondents for 375. That's less than 5, not less than 3, but less than 5. So we're pretty good here. You could argue it. You could definitely argue it. 0.005. It's not perfect. It is within range. So look at modification indices. There's one more, gender and age. Like I said at BYU, we might have that issue. Apparently we do. So I'll go covary those. And if somebody asks, just say, oh, it's totally context specific, and explain it. And we go look at model fit, and sure enough, 997, 10. And p-close, there we go. Okay. And then you report model fit. But now that we've done all this covarying, you have to rerun your analyses. Yeah.
So model fit before anything else, right?
Yeah. Model adjustments prior to hypothesis testing. Because you test your hypotheses with your final completed model. Okay. Yeah, we should have model fit prior to doing any hypothesis testing. Yeah.
I don't want to. The normality issue kind of bugged me. So I went off in search of a possible solution.
Good.
About when it's appropriate to use this approach and when it might not be appropriate to use this approach. And maybe offline I'll talk to you about using Mardia's coefficient.
Okay. And
if you fail the multivariate kurtosis test and the critical ratios test, then you might not want to use that.
There is a way to do that.
Yes, there is.
No, wait. We have
I can show you.
6 minutes. Give me a sec.
It's easy.
Any other questions on multi-group moderation testing? Okay. Right here, test for normality and outliers. And then, wait for it, run it, proceed. Oh, do I have to bootstrap?
I recommend bootstrap.
Let's just see if it makes it for us. Estimates, scalars, not there. Not there.
It'll be at the top.
Top. Here we go.
Yeah.
Mahalanobis. Not what I'm looking
Yeah, no,
for.
no.
Normality. Here it is.
There it is.
Assessment of normality.
Bummer dude.
What is it?
Bottom one. Look at your bottom
Oh,
one.
you gotta look at the bottom one?
Yeah.
What's it supposed to be at?
You've got kurtosis. The Mardius coefficient, the number, whatever the kurtosis number is whatever it is. But what you're looking for, the critical ratio, is to have that z-score below 1.96.
For the overall?
Yeah.
Oh, man. Well, the one that's killing it is age.
Yeah.
Yeah, so we might just chuck out age.
There you go.
Oh.
But you already knew that because you already knew that you had normality issues.
Yeah, we had kurtosis in age. We already knew.
Exactly.
So I might throw out age. I just want to play with this real quick. Sorry, and see what this does. So goes down. All right. So now we know. We can play with that.
Yep.
Interesting. Thank you, Laura. Okay.
Critical ratio that you were talking about?
Now it's all in the video too.
Okay, great.
So you drop age in your final model.
I just did, but I mean, you could say age didn't have any effect anyway. We observed it had 0 effect. That's another thing with controls. We'll talk about controls after lunch, but if they don't have any effect, you're allowed to just drop them. They're called impotent controls. Okay, let's have some lunch. I said yesterday we were going to go to the Museum of Art Cafe. They're closed on Saturdays, apparently. Awesome. So we have another place we're going to go. Let me just wrap things up here first. If you wanted to go with me, you don't have to. But Linda says, I didn't intentionally drop off my internet connection.
I was going to offer to take 3 people to Sundance as well, if anybody wanted to go up to the resort. It's about a 25-minute drive.
During lunch? Cool.
I have about an hour to have lunch up there. It's a little expensive, probably $25.
James?
Yes.
I did my mediation table, but I didn't know how to read it. Can I just share it with you?
Yes, go for it. I'm going to respond to Linda real quick. And let me turn off the recording for now.